Hi all, welcome to part 3 of the video lecture on physical data organization. So in the previous video we gone through the basics things, right, like fixed length, variable length records, and what about spanned as well as unspanned organization, blocking factor, etc. So now we will see different types of file, that is mainly this ordered as well as unordered files of ordered records as well as unordered record, and how these things can be stored, right. So again, the type of file allocation scheme we have for different types of database records. So first let's see how we are dealing with the files of unordered records. So typically such files are what we call as heap file. So that is just unordered in the sense, for example, if it is an employee database or a student database, and it is having collection of records. So each record is some related set of information, and when you are trying to store this in the database, there is no ordering. I mean, I didn't use this order by clause or nothing. Simply the records are stored in the database. Whenever something is coming, I am simply keeping at the end of the file, and I am storing like that. So there is no ordering at all. So definitely, when it comes to inserting a new record, it is very straightforward. Simply insert that new record at the end of the current set of records. So you can see what is the last block. You can trace it and take it to the. So whenever I have a operation insertion or deletion, that particular block is to be fetched to main memory, because the actual operation you have to do in main memory, and for permanent storage you can keep it in the secondary memory, something like that. So where, in which block you want to insert an element, take that block into the main memory and do that insertion correctly. In the sense, you just insert it at the end, that's all, because there is no ordering, nothing, right, and write it back to the secondary memory. So it's very straightforward to do this insertion. But when it comes to the querying and all, when you want to query some information, you want to search some information, there is no other way for you. The only option remains is linear search, because there is no ordering, nothing. You don't know where that particular information is going to reside. There is no guess. So you have to search records one by one in a linear manner. And for typical typically we will count this number of block access. One block may contain more number of records, so you can either count the actual number of record, how many record searches are needed, or typically the type of measure we are having is how many blocks are involved in the searching and all. Okay, so you can see if there are b blocks totally. So if I'm having b blocks totally, in the best case, in the first block itself you will get the information, because if you are lucky, and in the worst case you have to go up to the last block. Say there are totally b blocks, so b block access are needed. On an average, I can say that best plus worst by 2, something like that, b by 2 block access will be involved for searching an information, and it is very tedious process, and there is no other option, because there is no ordering of the records, nothing. So this is something called as a heap file, or just a pile of file, that's all. And the insertion is very straightforward, and the last block of the file is copied to the main memory buffer, the new record is added, and the block is rewritten back to the disk. So okay, so that's all. So if you want, you can so how can you trace the last block easily? So one way is at the file header itself you can maintain a pointer to the last block always. So whenever a new block is added, you just update the pointer. If you're doing like that, it's very easy. Just use that pointer and take the last block and update the record, that's all. So it is very straightforward. But when it comes to searching a new record, using any search involves, there is no other way, because there is no ordering, nothing. Linear search is the only way, and it is very expensive procedure. If only one record satisfies a search condition, then on an average, yeah, the program will lead to. So, and sometimes you have to go for b block search for sure. For example, suppose the information is not there in the particular database file, and another situation is like, suppose you want to know all occurrences of a particular field, right? So you want to know multiple, if there are multiple search result is going to give you true, in the sense the element is occurring multiple times. So for example, you want to know details of all students, say with CGPA above 10, so sorry CGPA 10 exactly, yeah. So what you have to do is, you have to exhaustively go for all blocks, and maybe in the last block also there may be a record with CGPA equal to 10. So the only thing is you have to do that b number of block access. Okay, but if you are satisfied with the first occurrence, and you just want to know a single student, say with CGPA, you can do that linear search. When you are getting the first occurrence, you can stop. In that case, the average number of block access will be b by 2. Otherwise, we will go to the worst case on an average even, that is b block access. So that about it. So typically we will use this organization with additional access path, say by means of indexing. So that we will discuss a separate topic, and we will see how this can be improved with the help of additional access path. So this particular organization, so insertion is straightforward, searching is not that much. Now about deletion operation, so definitely this deletion is also going to create issue in the sense that as the information is unordered and unrolled, and we are not going to worry about where information is getting deleted and all. But the thing is that when you delete some information here and there, first thing you have to search that information, then only the which information. For example, you want to delete all student details, say with the CGPA say less than 5, you don't want to keep, for example. I'm just taking example. You want to say delete all employee who are working in department number 5, for example. Department number 5 is not existing for the time being. If something like that, you have to search and find the employee record having department number is equal to 5. As it is unordered, we don't know, here and there, everywhere it may there. So for that searching, in the worst case, you have to go for B block access, right? If multiple occurrences you want to delete. Anyway, that difficult is there. And also, when you delete, suppose you search, you are doing that searching somehow, and you are able to delete, and in that case also, that empty space will be created here and there. Now the thing is that how nobody can utilize this empty, so it will retain like some internal fragmentation, because here and there I deleted some information and the space is free, and no other program is able to use this space, no other database file is able to use this space, still it is free. So what you can do is you can just some space is created in between, you fill that space with the records following it by making a backward shift, right? So but for doing something like that for each and every record, insertion is definitely time consuming in addition to the search time, right? But what we can do is we can use something called as a deletion marker. So with this deletion marker, what we will do, along with each record, it is something like a flag. Okay, so you will maintain this deletion marker flag, and that flag will be set whenever you made a deletion. So deletion in the sense, you want to delete the record, but instead of deleting it is completely from the database, we will simply set this flag saying that the information in this particular record is actually deleted, but in the sense it's not physically deleted, but it is virtually deleted. So future search and all, it will ignore such a deleted or such a to be deleted record, something like that. Anyway, what I'm saying is it is there in the secondary memory physically, but we don't want that particular record as part of our application, we delete it. Okay, so that is what we done by setting that particular deletion marker. So the future searching operations and all, whenever it is searching a particular record, it will first see the deletion marker. If it is already set, saying that it is not a valid information, it is something to be removed from the database. Okay, so such records with the deletion marker set will not be considered by search operation, and it will go nicely. So this is something you can do for every record. Whenever you want to delete, instead of physically removing it, you just set the deletion marker. Now periodically we will do something called file reorganization, where we will make everything perfect, in the sense all the spaces. So now suppose you during that periodic time when you are trying this file reorganization, suppose hundreds of records you deleted virtually, in the sense you made that deletion marker as 1. Now what you can do, you just do a single scan of the entire file, and wherever this deletion marker is equal to 1, you do that backward shift or something. But now the thing is that all the deletion we are handling together in a single stretch. So in between you are not spending extra time for that, right? And all of them you are doing together. So on all together, so for each record you are shifting everything backward, or some 100 record together, all together you are shifting backward, which is going to save you the time. So definitely that parallelly doing things, right? So this is going to save time. So that is one variation you can think about. So just go through the theory part, that to delete a record, a program must first find the block. So that will incur some time, and deleting some large number of records in this way is going to waste space, in the sense here and there, that internal fragmentation kind of thing. So what we can do is to use a deletion marker. Record is deleted by setting the deletion marker to a certain value. So maybe if it is just a boolean 1 or 0 like that, that also fine. A different value for the marker indicates it's a valid record. Okay, here okay, even 1 or 0 is fine. Search program consider only valid record, in the sense for which this particular field is not set. So both of these deletion techniques require periodic reorganization of the file to reclaim the unused space of deleted record for some other program. Okay, so during reorganization the file blocks are accessed consecutively and records are packed by moving deleted records, and all of this packing, moving, everything will happen together at some periodic time. Okay, so that about it. Now what else? Modification is another operation that you can think about. So we can use either spanned or unspanned organization for anyway back on background. It can be fanned and spanned, unspanned, or fixed length or variable length records. All those things are there. Now when it comes to modification, the problem is for fixed length the modification, you just have to locate it, and after that modification is straightforward. But when it comes to variable length field, and when you are modifying it, it may be some optional field. Now it is not optional, now it got some values like that. You have different ways of modifying the variable length record. So definitely chances are there this record size is going to increase. So previously it took some sequence of bytes, but after modification, if the size is reduced, definitely it is going to create some empty space in between. If the size is going to increase, you are not able to put it in the place before. So what we can do, so it may require deleting the old record. So this is the only way, because if the size is going to increase and all, you have to delete the old record and you have to insert it as a new record. And insertion is something straightforward. You can just put it as the last record in the last block, and you are already keeping track of the pointer to the last block. Anyway, okay, so again for this deletion you can make use of the deletion marker. Anyway, what we are doing is modification of some attribute actually, but for fixed length record modification is straightforward. Simply modify that field. But when it comes to variable in the record, it is not good to go for the straightforward method. Rather, you can do something like the delete the old one and insert it as a new one, maybe like the insertion procedure as well as a deletion marker, everything you can make use of. And again another operation you can think of, the sorting operation, that is also going to be an expensive operation. Right, now let's see about the last variation called so here you can see everything. The simplest thing we are taking like unordered fixed length file. So when it comes to we are discussing about unordered files only, but when it comes to ordered file, that is actually we have some difficulty in ordering them. Anyway, this is the simplest one, right? And it is fixed length. Again, it is straightforward, and we are using unspanned organization also. So keep all these things. All are these direct easy versions, right? Unordered record, fixed length record, and unspanned block. Okay, so everything is straightforward, and we have a contiguous allocation also. Again, this is also straightforward. In that particular case, you can think about something called as relative or the direct file. So what we are doing is, if the file record, so each record we are numbering, so totally I am having r record 0 to r minus 1, and if you are looking at a particular block, within a block we have a BFR, blocking factor, that many records, right? So if I am numbering like a 0 to BFR minus 1, where BFR is a blocking factor, then in general in the original file, the ith record of the file is located in block number I by BFR or I mod BFR. You can think about it as an example. Suppose I have records like 0 to some 999, and within a block I can just store 10 records. Now the question is, in which block this not in which block. So if you are looking at the block number, then you have to divide it, but the mod operation is going to give you the relative position of record in that particular block where you are allocating that record. Okay, so it is something like the same example you take. So I have a totally 1000 records, 0 to 999. Okay, 0 to 999. Let me just write here 0 1 etc 999. So this many records I am having, and blocking factor is found to be 10 0 1 etc to 9. Okay, now you know my question is in which block this block number 23 belongs to. Okay, and that time you just take this 23 by 10, it is going to give you the quotient as 2. So block number 2 this will reside. So if I am starting numbering like from block number 0, so in 0th block I'll be storing 0 to 9, and the block number 1 I'll be storing from 10 to 19, and block number 2 I'll be storing from 20 to 29, and that is where this is supposed to be. And in the block number 2 itself, if you take this mod value, I mean 23 mod 10, 23 mod 10 is going to give you 3, and says that in the block number 2, that is a quotient, this particular record is at a position 3 0 1 2 3 like that. Okay, so the relative position of that particular record in the block is something straightforward for us. Everything is because we have fixed length, unordered, unspanned, and contiguous allocations, because all are straightforward. That's why this is happening, and this is something known to be the relative or the direct file. Okay, let me remove this example and all. Fine, you got it right. So now that about it, and then similarly another organization that we can think about is the files of ordered record in the sense in the secondary memory. When I mean in the application is having a requirement that this particular records are to be ordered with respect to a particular field. For example, you are going to order all the records, say using name attribute, and say name of the employee. It can be key attribute, but name, it's different people may have same name. It can be non-key also. Whether it is a key attribute or non-key attribute, you are going to store them with respect to that particular attribute. If it is a key attribute, when you are ordering, there is no issue. I mean, continuously these fields will come. But when it comes to a non-key attribute, and if you are ordering, same name will come together. Okay, so like that, so it will form something like a cluster. So that is something, a variation of it. We call it as a clustered file also. Something it's given here. So clustered file is nothing but the files of ordered record, and that particular field with by which you are doing this ordering is a non-key. So that's why you are getting a cluster, right? Okay, anyway, got it right. So where we need or what is the advantage of having such a ordered file, in the sense, so sometimes it's very straightforward, right? So reading as well as searching, as well as I want to know the range of employee having this name, but everything should involve that ordering attribute. For example, you already sorted or ordered the records of the file with respect to employee name, and I'm asking you what is the salary of employee with the name, say starting with the letter M, say employee with the name Manu something, and what you have to do is M is a starting letter, and alphabetic ordering I am following, so I can go for binary search. That's the benefit, right? Main benefit. So when you apply binary search, you can find out that position of M. If it is unique, then it is very straightforward, position of Manu, and you take that records. So in the previous case, when it comes to unordered records, the only one option to trace some information is linear search only, but here you can go for binary search. So that is the benefit. Okay, binary search, and also for getting some three situations are given. So just go through it. So where we need ordered files. Now when it comes to ordered file, we have to think about the operations that we discuss in case of unordered files also. For example, starting with the insertion, deletion, etc. Insertion, there it was straightforward. For unordered records, simply insert it at the end. It's straightforward for us, but here it is not like that. After insertion also, you have to maintain that ordering with respect to that name attribute. Okay, so I'm just inserting so somebody say the particular record is having some name. You have to put it in the right place, so that involves some searching to locate the place. Maybe the binary search you can use, and once you reach that correct place to insert that record, someone else will be occupied that place, right? So everybody, you have to shift downward, and you have to create a space for this new information, and you have to put it there. So that is a difficulty we are facing. Now how can you overcome it? One way is something like overflow block. So you can make use of some overflow file or transaction file in association with every block maybe, or for the entire file. So the entire file, the original file, is what we can call as the main file or the master file, and now this overflow file is something extra, and new insertions we will keep in the overflow file, and also we will maintain a pointer from the record following which this should be inserted. Okay, so you have to trace the location of a particular record. I am saying that this is to be inserted after the 100th record, but after 100th record someone else is there, but instead of moving everybody downward, what I am doing is I am putting that new record in a overflow block. Then at the end of that 100th record, I will maintain a pointer, and this pointer will be pointing to this overflow block, saying that following this 100th record, the next one is in the overflow block. Okay, so like that, for the time being, we will insert everything in the overflow block, and we will properly maintain that record pointers. Okay, where this particular one is available now again we have this file reorganization, right? And that time you can insert everything in the right place by doing them in a parallel way, in an altogether way. For example, suppose some 100 records I inserted, all of them are in the overflow block, and I maintain that pointer correctly, say by doing binary search and all. Now during file organization, all this 100 record you place in the right place together, and all the shift you do together. And similarly, for deletion, both are expensive of course, but this is the only way we can achieve it. And we are getting the benefit of searching as well as sorting, right? So that is the speciality of this organization. And deletion also, we can make use of the deletion marker technique that I already explained you, and during all the reorganization time you can do the deletion permanently, something like that. Now what about modification? Again we have difficulty, like whether you are modifying the fixed length field or variable length field, something like we encounter so far will occur. And also here additional difficulty we are having, if you are modifying a record and you are actually modifying the attribute on which this record is ordered. For example, name of the employee, and with respect to that name the records are ordered already, and suddenly I am changing name of a particular person, say suppose due to some reason he changed his name or some other attribute, whatever it is, and that time you have the difficulty, now this is not the right place for this record to stay, right? Because its position changed because I changed the name. And what I have to do is the original record I have to delete, and I have to put it as a new record in the right place, maybe with the help of the overflow block and all. So that is the challenge we are having when it comes to modification of the say if it is ordering attribute, I am having this difficulty. If it is a non-ordering attribute, this is straightforward, simply you modify it. Okay, the difficulty I am having is with respect to modifying the ordering field, means that the record can change the position that you have to take care, right? So this requires the deletion of the old record as well as insertion of the modified record, and by following the deletion marker, insertion of flow block, etc. And even though this much benefits, the benefit side is something like we can go for a linear binary search instead of linear search, and all the records are available nearby, so if you have some range queries and all, you can fetch them easily and all. But the insertion, deletion, everything is costly, right? So all together, and every time when you insert a new element, you have to maintain that ordering. So that is the type of difficulty we have having. So because of that, even though it is found to be a better one when it comes to search as well as range queries, we are not following it. So typical organization is actually unordered organization, like that heap file. And in addition to that, to get a feel of this ordered record, we will maintain something called as indexing, primary indexing. Anyway, this indexed sequential file or this indexing concept we will see in detail in our upcoming video, and that time you will understand that with the help of this indexing and unordered records can be handled in a nice way. Okay, so if I have a file of unordered record, don't worry, use that indexing and handle them like before. Insertion, everything is straightforward. When it comes to searching, this indexing file is going to help you for searching, and we will see how it is working. And this ordered record, that concept is typically not used. Okay, so not used much, but if you want, you can go for this also on way. And there is a variation called the clustered file, as I already told you. If we are doing this ordering on a attribute which is not a key, definitely all people with the same what can I tell you, with all attributes with the same key value, I mean no attribute value, it is a non-key. If it is a key, it is just distinct. If otherwise all people with the same name, if it is not a key, the same name will come together, so it will form a cluster. And the same concept, instead of sorted file, you can call it as a clustered file. So we discussed heap file, sorted file, and slight variation of it called a clustered file. Okay, heap files are nothing but the files of unordered record, and sorted files are nothing but files of ordered record. And typically the files of unordered record or heap file with indexing is a combination that we are mostly using in practice. And clustered file is again the same sorted file concept, but ordering is done on a non-key attribute. Yeah, that about it. So this is something we discussed so far. If it is a heap organization which is for unordered files, the only option remains is linear case search, and on an average it will take b/2 number of block accesses. But when it comes to ordered organization, there are two types of search again. If the searching is based on that ordered attribute, I can go for binary search. Okay, suppose I ordered the database records, say using name of the person, and you want to know, you are interested to know the details of a particular person, say with the name Madhu or something, you can go for binary search. But if you're interested to know about the details of an employee, say, who is working in department number 5 or something, and that and with respect to department number, we didn't order it so far. Okay, so the only option remains a sequential scan. So it involves both binary as well as sequential search, and accordingly, if it is binary search, you will get this logarithm of b to the base 2, and you know how we are getting this logarithm searching time. Okay, so this many block accesses, we are just counting block accesses, but actual execution time is slightly more, in the sense within a block there are many records, and that you have to trace the actual record also. Yeah, thanks for watching. So maybe in the next video we will see one more file organization kind of thing called hashing, hash files, and then we will see that indexing, that is a flaw. Yeah, thank you for watching.